looking at problem 2a from section 5.3. So the function that we're given is cubic, x to the third, 12x squared, 45x, and plus 2. Okay, so that's, we're trying to find the intervals of concavity, so second derivative is what we need, so we'll take the first derivative, so minus 24x and then minus 45. And then let's go ahead and factor this, so it'll make it easier to find the zeros of this thing. We'll factor out a negative 3 first, and that'll leave us with x squared minus, or actually plus 8x and plus 15. Okay, so there's the first derivative. Let's take the second derivative of this thing. In fact, actually, I guess I didn't really need to factor it. That's okay. Let's take the second derivative from here. We'll get minus 6x minus 24. And for the intervals of concavity, we need to set this thing equal to 0. But before we do, let's factor out that negative 6. So we get x plus 4. Okay. And if we set that thing equal to 0, we'll get basically just x plus 4 equals 0. Okay, so that tells us that x equals negative 4 is a possible inflection point. It's a place where we might have an inflection point. Remember, we don't call these critical because we're not talking about the first derivative here. We're not talking about increasing, decreasing. We're talking about concavity. So that's a possible inflection point at x equals negative 4. How do we determine if we actually have an inflection point? We set up our intervals minus infinity up to the critical number, or the possible inflection point. And then from there up to the next one or to the end of the domain. So there's only 2 intervals that we're looking at here. So it's nice and short. In fact, we probably could get away with not even having a table here. We're just going to check 2 numbers. So on this interval, let's pick minus 5, and then on this one, let's pick 0. So if I plug in minus 5 into the second derivative, here it is. Here's the second derivative. Minus 5 plus 4 is a negative number times that negative that's already there. We get a positive number. If I plug in 0 there, I'll get a negative number. Okay, so what does that tell us? The function is concave up on that interval, and then it's concave down on the second interval. Okay. We were also supposed to find the, oh, actually on this one it just says to find the intervals where the function is concave up or down. We've done that. So that's it. It's concave up on that interval from minus infinity to minus 4. And it's concave down on this interval from minus 4 to infinity. Okay? Come back and do B.